with this graph here, I have several different options that I can use when I'm finding the equation for this. It tells me I want to find it in terms of a secant. Okay, I can choose to use a positive or negative in front of my secant. The answer can be either one, and I'll show you how to do it for each. Okay? But the way that you would set up to solve for this is we're looking at a function that has some value in front of our secant, and then the secant's going to be something inside, and then some shift that happens, and then it has some vertical shift in front as well. So again, what I can do is I just need to figure out what each of these individual pieces is. So the easiest thing is probably to find this. This corresponds to the midline. Okay, so D is my midline. So if I find the halfway point between my minimum here and my maximum here, so between 1 and -7, if I add those together and cut it in half, that gives me my midline. So -7 plus 1 divided by 2 gives me -6/2 or -3. So here is my midline. Okay, so I know that my midline is going to be a -3. So there's my D value. Okay, now my A value is going to be the distance from the midline to my max and min. It should be the same distance. So if I count up 1, 2, 3, 4 units up, 1, 2, 3, 4 units down. So my A value is going to be 4. Now, again, I mentioned I can have this be a +4 or a -4, and I'll talk about how to choose that here in just a minute, but I'm going to go ahead and just leave it +4 for right now. So I have 4 times the secant of, okay? And so what I need to do is determine inside here, I have an x minus c. Well, my c is going to be my horizontal shift. So the fact that I have a point right here at the intersection of my y-axis at the x value of 0 means that there is no shift. So I'm going to use my c value as a 0 right here, because what I can now do is just put the period in front, or the b value based on the period in front of this function. I've got my complete answer. Okay, so if I find out how long it takes for this graph to repeat itself. So when I look at the corresponding cosine function, I have maximum, midline, minimum, midline, maximum. So there is one period. So if I were to take 2 pi divided by b is equal to my period, which I see as 2/3, what I can do is solve for b, and that's going to be the value that goes here. So the way I can solve this is if I multiply both sides by b to get b out of the denominator, and then to isolate b, I'm going to multiply both sides by the reciprocal here, 3/2. So the 2's cancel, the 3's cancel, I get b is equal to 2's cancel, 3 pi. So there is my b value. So this right here is one possible function I can write for this graph. I'm going to go ahead and simplify it a little bit by writing 4 times the secant of 3 pi x. I don't have to worry about the -0. Okay, and so this is my answer, or this is probably the easiest answer to create. Now, I had mentioned earlier that you can put a negative in front if you want. Okay, so if I wanted to put a negative in front, so if I thought of my a value here, my first number as a -4 times the secant of, everything else stays the same except my shift might change. Okay, so I still have the -3 outside, but this shift changes. And the shift changes because I'm no longer starting, if I use the negative out front, I'm no longer starting with a maximum, I'm starting with a minimum. So what I have to do is I have to shift my graph over to start here. So now I would start at a minimum, midline, maximum, midline, minimum. So the cosine that I'm using for a -4 in front of my function, I'd need to shift here 1/3 units to the right, so x minus a 1/3. So this would be an alternate form for my function, which again, if I distribute through, I get f of x is equal to -4 secant of, and if I distribute this through, I get 3 pi x minus here the 3's cancel, so minus pi, and then the -3 out front. So This is the answer that I would prefer. It's an easier answer to find, but if you put a negative in front, this would also be a potential answer for describing that, or an equation that describes that same graph.